Motion distant time graphs. I can measure and graph changes in motion. For your starter, we're going to calculate the acceleration of a suitcase that's in the back of this car. A 300 kilogram suitcase is placed in the back seat of a vehicle. The vehicle accelerates from a resting point and increases 60 miles per hour. Suddenly, the car crashes into a concrete barrier, causing the suitcase to hit the dashboard with a force of 400 newtons. So what is the acceleration of the suitcase? So let's find out what we're given. So looking back, we are given the mass of the suitcase. I know this is mass because kilograms are my units for mass. I'm just going to put that up there. And what we also have here is the speed, which we don't need, and we do have a force of 400 newtons. Now I know this is the force because newtons are the unit for force. So if I want to find the acceleration of the suitcase, first I need a formula for acceleration. I can get a formula for acceleration using the formula triangle. If I cover up my acceleration, my formula reads force divided by mass. So acceleration equals force divided by mass. So I would just simply plug in my numbers. So the force is 400 newtons, and the mass of the suitcase is 300 kilograms. So I would just simply divide 400 divided by 300 to get my acceleration of the suitcase. Remember, acceleration is in meters per second squared. So you would want to have those proper units for acceleration. What could have thrown you off in this question is here when they're giving you this extra information with speed, something we don't need. Today we're going to have a class reading. We're going to read slides 2 through 6 on distant time graphs. Motion is a change in an object's position relative to another object. The motion of an object can be shown in a graph. Graphing distance versus time, we can tell about an object's motion. Time is always plotted on the x-axis, while distance is plotted on the y-axis. So again, time is always plotted on the x-axis, which is the bottom of the graph. The further to the right of the axis, the longer the time from the start. So here's your starting point, and time is going to increase as you go to the right. Distance is plotted on the y-axis. The higher up the graph, the further from the start. So here's the starting point, so this point here would be the furthest distance. If a force, a push or a pull on an object is applied to a moving object, the object can speed up, slow down, or come to a stop. A force can also change the direction an object's moving. If an object is not moving, a horizontal line is shown on the distant time graph. Time is increasing to the right, but distance does not change. It's not moving. A straight horizontal line shows an object at rest or stopped. So here is your horizontal line. You can see time is ticking by, but distance is not increasing. If an object is moving at constant speed, it means it has the same increase in distance in a given time. Time is increasing to the right, distance is increasing constantly with time. The object moves at a constant speed. An upward slope straight line on a graph shows constant speed of an object. So we can see distance divided by time would be equal at any point along this graph. Constant speed. Comparing two lines. Both lines in the graph show that each object moved the same distance. So if we take our distance across, we can see it's the same distance, but the steeper dashed line got there before the other one. The steeper line indicates a larger distance moved in a given time. In other words, increased speed. Both lines are straight, so both speeds are constant. Graphs that show acceleration look different from those that show constant speed. The line on this graph is curving upwards. This shows an increase in speed since the line is getting steeper. In other words, in a given time, the distance the object moves changes, getting larger. It's accelerating. So here we can see that we are increasing our speed here, so we are accelerating, and you see the curve. Graphs that show a return to the start or a return to the point of origin looks different from those that show constant speed away from a point of origin. The line on this graph shows an object returning to the start at a constant speed. So remember, your point of origin of start is here. So if you have an object going like this, it means it's returning to its starting point. Summarizing distant time graphs. A distant time graph shows how far an object has moved with time. So distance and time. The steeper the graph, the faster the motion. So here we'd have a very fast object. A horizontal line means the object is not changing its position. It's stationary. It's not moving, it's at rest. A downward slope line means the object is returning to the start. So here we have an object returning to its start. Okay, so using this summarization, we're going to answer some questions. So which of the graphs shows that one of the runners started 10 yards farther ahead than the other? Okay, so looking at these graphs, you want to see one runner starting 10 yards further ahead than the other. They're both going probably the same distance, which is 20, but you see one starter started ahead of the other. In which of the following graphs below are both runners moving at the same speed? Explain your answer. Okay, so same speed, both runners running at the same speed. Explain your answer. Tales from a graph. What information is shown in the graph? The information shown is, and you would type here. What do I notice about what's shown in the graph? I notice, and type here. What information is shown in the graph? The information shown is, and you would type here, and type what you notice. The information shown in this graph is, and you notice. The information shown is, I notice that. And then the information shown in this graph, and what do you notice? You can refer back to the summary and notes to answer those questions. Okay, here we're going to look at a different graph. So now we're not looking at distant time graphs, but we're looking at speed time graphs. So here on your y-axis you have speed, and then on your x you have time. Notice that time increases as you go to your right. Same with speed, it's increasing as you go up. Speed time graphs look much like distant time graphs. Be sure to read the labels. Time is plotted on the x-axis, or speed or velocity is plotted on the y-axis. A straight horizontal line on a speed time graph means that the speed is constant. It's not changing over time. This graph shows increasing speed. The object is accelerating. It's accelerating because we're changing the speed. This graph shows decreasing speed. The object is decelerating. Comparing two lines, both the dashed and the solid line show increasing speeds. Both lines reach the same top speed, but the solid line takes longer. The dashed line shows a greater acceleration. Connection, summarizing speed time graphs. The speed time graph shows us how the speed of a moving object changes with time. The steeper the graph, the greater the acceleration. A horizontal line means the object is moving at a constant speed. A downward sloping line means the object is slowing down. Okay, so you're going to use the information above on the last slide to describe the motion of the bus through these points.